mobility and also in production applications. And we are focusing on the one side on mobility system. Here on the left picture, you can see a small an demonstrator car, which we will empower with an fuel cell within the next years. But the main focus of our institute is the production technology behind such systems, which means also let's say the hard machinery, forming presses, cutting processes, coating processes, and so on, but also the quality monitoring of such components. Next slide, please. Here we have a small overview over a very interesting project where we are developing in the first step electrical micro-mobility solutions, which means they are not powered by an fuel cell, but this will be the next step beyond this project. And as you can see here, we develop on the left-hand side together with our Czech partners a charging station for some small scooters, and behind you can also charge some electric cars or bikes. So it's a very modular system, and also with a mobile app behind where you can do the fleet management and the payment and all this stuff. In the middle, you see an electric trike, heavy-duty trike, which was constructed of a local partner near to our institute. And here you see some of the works we are doing. We are focusing on the mechanical simulation of the frame structures of this case. This is not, we are developing two cars. One is the trike and one is the scooter. And here you can see a simulation of the frame structure of the scooter. Our partner, Czech University in Ostrava, they are developing also some test tricks, because we when we prepared the proposal, we faced, or we found out that's really a problem, that there is not enough testing capability available for such new systems. So maybe next slide. I already introduced that we are working in depth in this fuel cell topic. One of our recent projects is that we are participating on the development of a demonstrator stack system, and especially we are producing the bipolar plates for the fuel cells, and also let's say the frame structure of this fuel cell. Behind, we are developing simulations models, as well as for the electrochemical behavior of the fuel cell, and also for the traction system, also the energy flow from the fuel cell over the power electronics to the road. So here you can see some basic results where we simulate the electrical behavior of the fuel cell under in different operation conditions. And very important issue we are focusing in is the embrittlement due to hydrogen, because hydrogen is a very aggressive medium for the metal parts, and there we are currently building some testing system to have some life cycle tests of all the mechanical components, valves, pipes, and so on. Next slide, please.
Just a moment.
The next slide includes some video, maybe the...
okay. Maybe.
It takes maybe some seconds before it switches.
I don't know why. Oh, just a moment.
No, okay.
Now it should be...
One.
Yeah, here.
Now, okay. So I already mentioned that we are focusing mainly on the production technology behind the fuel cells or car component, car body components in a general. And here you can see some system we built on a press job floor, really at an automotive producer. And here we have some monitoring bridges with several cameras, up to 30 cameras right now, and they are doing an inline inspection in the production of these components. So unfortunately the video is not playing, but I think this doesn't matter, so we can switch to the next.
We can try or not.
Maybe here you can see the the car door is moving through this camera bridge, then pictures are taken. You can see the flashes, and then the system detects some cracks, and here you can see the body, the car body part was marked as 40, and this is the reason why this red LED bar is moving with along with the movement of the car body part. Next slide, please.
Okay.
So then we moved from the big car body parts to this innovative hydrogen bipolar plates. And we are currently in the ramp up phase or the engineering phase of our monitoring system. Here you can see a simulation where we are optimizing the camera and illumination arrangement, that we have an optimal coverage of all the features we want to measure and do in quality check. We also have an inline measurement system for the welding processes that are associated with the bipolar or the fuel cell production. And here you can see an example of this. So we have a combination of different optical, thermal, and non-optical sensors to have an inside view of the welding quality. Next slide, please. So that's only a small overview about our activities. And I would also use the chance to invite you to the Energy Days. We are organizing this year in September in Chemnitz, where we present especially the solutions I showed on the first slide with this charging station and the mobile, this mobile trike and the scooters. So, and I invite you to come to Chemnitz and see not only the slides, but also the real system. Next slide, please. So that's the end of our presentation. I included 2 videos. Maybe Igor, you can click on also on the gray one. The videos are showing some other activities. So
Alexander? Alexander? Hi.
Hello. I guess
Hello.
something came on. I don't know.
Miriam, are you here?
There was a problem. Yes, I'm here. I just to preserve my data.
Where Serdar, are you out? Here, Serdar?
I don't know, actually.
We have lost all camera, all videos, yeah, and all camera.
Yes.
I don't know why.
I don't know why. Me too.
Okay.
Just all of a sudden.
Okay, Serdar, can you hear me? Okay. I don't know. Jan, can you hear me? And our technical support. Okay, yeah. I can hear, but I don't. Okay, I know. So when the video played, the webcams dropped. Maybe so, yeah. Maybe so. But I don't know if we lost Alexander, but Miriam, now I will change it for you presentation, yeah?
Okay. Can I begin?
Just a moment.
Okay.
Just a moment. I'm writing to our technical support.
Sure.
Okay. Miriam, now I do it to a big presentation. Just a moment. Yes, you see it.
Yes.
Very good. I would introduce Mariam Hassan from Tunisia and at the same time France. She's acting on the field of significant energy projects that have been implemented in Tunisia and in France. She will present her projects, very interesting projects connected with Tunisian administrations and with the French company Himod. I think it is so, but Mariam will tell us more about it. Yes, you're welcome.
Yes. Thank you, Igor. Good morning, everyone. I'm Mariam Hassan. I'm an industrial biology engineer, and I'm in my final year of master degree on renewable energy systems in Africa. So today I'm going to present my project about waste to energy project. It's actually our waste is municipal organic waste. And for the end use for eco-mobility in Sfax. Sfax actually is the economic capital of Tunisia. Next slide, please. So my agenda today is I'm going to present the CEA RRO, and then I'm going to present the MEDUS project. Next slide, please. Next slide, please. So before I present the CEA RRO, RRO is la représentation régionale opérationnelle de CEA. But I have to present CEA before the representation because CEA actually is the mother organization. It's a French energy. It's a French research center. It works about the crossroad of three transitions: energy, digital, and medical. So actually, CEA was founded by Charles de Gaulle in the Second World War for military goals. So it was a research center based on nuclear energy, and it was made for the French military so they can be very competitive on military basis. But now CEA works more on civic, let's say, or civil fields like renewable energy and the use of nuclear and medicine and like really more common subjects, let's say. Next slide, please. So here are some of the missions of CEA. So we can say like CEA is really the objectives and the mission of CEA goes in hand with the French national strategy of energy and of research. And it has a really big impact on the French society and even the French military strategies. Even for now, like they have a really good impact. Next slide, please. So here are some numbers. We can see that CEA is implemented all over the French territory, and it has like 6,000 patents and 4,000 publications per year, and the numbers are really huge. So you can ask for Igor to share with you this representation for more information, or you can search for CEA for more information about it. Next slide, please. So CEA actually it has really good impact also on the French industry because it helps just transfer the academic and the fundamental research to industries and to create startups to make the French industry competitive on the international level. So it has really great impact on the French industry and on the growth of the startups and the technological level in France. please. Next slide. So these are some of the priority subjects that SEA works on, and these subjects like go hand in hand with the 17th goal of SDGs. I'm not going to spend a lot of time on this. So
Yeah.
next slide, please. Yes. So here is the implementation of the regional operation representation of SEA in Tunisia. It works for the development of projects and the facilitation of the contact between the French industries and the African and Mediterranean countries, so they can like implement the projects in here and help these countries to become more competitive and help them in their energy transitions and their all the transitions they want to achieve. Next slide, please.
Just a moment.
Yes.
Yeah.
Next slide, please. I'm not going to spend so much time on this.
You see the slides, yes?
Yes, I can see the slides.
Okay.
These are some partners from Tunisia, Morocco, Algeria, and Mauritania. Next slide, please. Next slide, please.
Meduse.
So now it's Meduse project. Yes. Next slide, please. So Meduse, it means in French jellyfish, but for now it's not about jellyfish. It's Meduse is the acronym of Management efficient des déchets et usage du syngas en écomobilité. Means efficient management of waste for use of syngas in ecomobility. So this is the project I'm working on in Tunisia, actually, with the representation of SEA and Kimod. Kimod is the French industry that makes the methanation reactors. So as we can see later, next slide, please. So why this project? Actually, Sfax is the economic capital of Tunisia. And last year, there was so many strikes. The municipality didn't collect waste for like 2 months, so there were waste all over the town, and people like were really angry, and there was a really social problem that threatened the overall situation in Tunisia. So there was so many strikes, and everyone was angry. There was so many people that got sick because of the waste all over the country and everything. Because there was a problem in the landfill. They closed the landfill. So that's why the municipality had the strike. Next slide, please. This is our first problematic, and our second problematic is that the liquefied petroleum gas is forbidden in for commercial use. Actually, these are texts from Tunisian law. Sorry, it's in French. I didn't find the English version, but these texts just say that the LPG is forbidden. But in Sfax, taxis still use this, and they just make something by themselves. It's the DIY thing, and they because it's much more cheaper, and the gas is really expensive in Tunisia. So it's when they use LPG, it's so much cheaper, but it's forbidden by the law. So next slide, please. So why we choose Sfax? Because Sfax, it has a potential of 650 tons per day of waste, of municipal waste. And people there, they use the taxis, and the drivers are the most, the people that use the most the LPG for mobility, but not in other towns in Tunisia. So that's why we choose Sfax. Actually, that's the map of Tunisia, and Sfax is on the shore. And actually, there are another problem is that the LPG costs to the government 36.3 million Tunisian dinar, and it's really huge amount of money. So next slide, please. So this is the concept of our project. We are studying a biogas facility, but it's a mixed biogas facility. Why mixed? Because actually it has methanization, the biological process, and the methanation is the chemical process. So how we will begin? We will begin by collecting the organic municipal waste. We make a sorting to just have only the organic waste. So the organic waste passes to the methanization, and we have the digestate, and we have the methane. But we have also a huge amount of CO2. So that CO2 is valorized. We are going to valorize it into the methanation. So the methanation, the principle of the methanation is it's the reaction of Sabatier. The reaction of Sabatier consists of transforming the CO2 into CH4, into the methane. So we have like 100% methane and no CO2 emissions into the environment. So we can use the biomethane, or yes, it is the biomethane, into ecomobility, and we can inject it in the gas network, and we can use it for auto production. Mm-hmm. Yes. Next slide, please. Mm-hmm. So our project, because the CEA aims to integrate the local industries in the projects. So not only France who makes the project in Tunisia or in other countries of Africa and Arab world. They have to be local industry who participates in the project. So in our local industries, they are going to build the facility, and they are going to help into the civil management or civil stuff. Next slide, please.
Okay, Miriam, please, 1 minute and finish.
Yes, next slide. Yes, next slide, please. Just click, another click. So these are the benefits of our project. Actually, the project goes in hand with the waste management strategy of Tunisia. So we have an economic viability because we just made the economic study. We have a positive environmental impact because it reduces CO2 emissions. We have positive social impact because it creates jobs, and it builds the industry of the future of Tunisia. And thank you for listening, and I am sorry for being too long.
No,
thank you.
Thank you very much.
Thank you.
Yes, thank you very much. Very interesting presentation. I would like to ask our Dr. Thomas Walter, who is Managing Director of Easy Smart Grid GmbH in Karlsruhe, in Germany, and is a well-known expert on all these subjects, is working on the field of electricity efficiency and mobility and industrial automation also. Dr. Walter, we would like to ask for your opinion, for your vision of the current situation on this field. Thank you.
Thanks, Igor. Can you hear me? We had some problems with the microphone before.
Very, very good. Yeah.
Okay. Thank you, and thank you for inviting me. And I don't think I'm that well known as you announced in your speech just now, but maybe this changes. Thanks for having me here, and thanks for also having my point, which might be complementary to that of the other speakers. Now, not everybody may know EE Smart Grid. So we are working on how to manage a decarbonized energy system. You know that the growth of renewable energy will mainly come from solar and wind. Now, they are intermittent sources, as everybody knows. So sometimes they're there, sometimes they're not there. And that requires a lot of changes to the energy system. And that is what we are working on, how to actually coordinate supply and demand at any point in time. Now, what we are talking about is an energy system which is much more based on electricity. And the subject of today was electric fuels. So I will only focus on that, not on natural waste like the speaker before. And these fuels will have to be produced from renewable sources, such as solar and wind mainly. Now, my role in this discussion is to put some water into the wine of e-fuels, and to give you reasons why I'm convinced that they have a much smaller role than many people think. And if you are an investor, what I will try to achieve is to avoid stranded investments, investing in things that will not come. I would like to point on two key observations. The first is the inefficiency of e-fuels as compared to direct electrification. So if you have an electric vehicle and if you have a combustion vehicle powered by e-fuels, for the combustion vehicle, you probably need 5 times as much renewable energy than for the battery vehicle. That means for a given mileage, you have to install 5 times as many windmills or PV panels. Now, that's not the only problem. You're also competing on these carbohydrates with the chemical industry. For example, because all the plastics we are using today are also made from oil and gas. Now, some people say, well, we need, for long distance travel, we need it because batteries will not last 1,000 kilometers. This may be true, but I think somebody has invented railways for this problem. So why not put the transport on railways rather than saying, well, I want to have my car to drive 1,000 kilometers. So that's the first point. That's the relative inefficiency. Sorry, somebody's ringing my phone here. I stopped it. So the second point is because of this relative inefficiency. Mobile phone? Terrible. Sorry. Because of that, the scarce renewable energy that we have, and in Germany we have some 15% of our energy uses of renewable energy, means that you have to actually use it at its best and most efficient carbon effect. Now, so simply there will not be enough renewable energy in the short term. Now, what does short term mean? There is a very good study done by the Florence School of Regulation on the subject. And when you read it, and I'll put the link in the chat, you will probably agree that for the next 20 to 30 years, there will not be enough renewable energy to make any e-fuels if we want to go for an efficient decarbonization. Now, there are people who are saying, well, if you cannot make it in Europe, why not import it from Africa or other countries? Now, the countries that are typically discussed have a very low share of renewable energy today, and they should actually use the renewable energy they invest in the next years to decarbonize their own system. It would be much better for the climate. Thank you for your attention, and I hope we are going to have a good discussion. Thank you.
Thank you very much, Thomas. Yes, there are some questions, and I have some questions for Alexander Pira, who is listening to us or not. Alexander, are you here? Alexander? No. Yeah, Alexander, can you hear us? Okay, very good. Alexander, I have some questions about on your presentation. Yeah, tell us, please, just a little bit more. Are there some prototype models of these mobile trucks, for example, that you will present on Energy Days in Chemnitz? Do I understand it right way or not? Oh, no, 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 we don't hear you. Unfortunately, we don't hear you.
Alexander, you have to leave the loudspeaker, switch it off, and switch it on again, and then you'll get the micro.
Alexander, please try to do it. Okay. Yes, now Alexander is answering us in written form. Very good, very good. I had another questions about to your presentation, but if we don't we can't hear you, it's doesn't make sense now. Maybe you can restart it or do something that we can hear you. Yes. Miriam, please tell us. Miriam, do you hear us? Yes. Very good. Very good. Yes. 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 You told us about many startups. Yes.
Yes.
Are they created already? And if so, then where are they created? These startups.
Actually, the startups are created in France because the CEA helps the French industry and the French environment, business environment, to develop and to be more competitive. So I think that Kimod is one of the startups that had the brevet, the patent to make the methanation reactors. Actually, these methanation reactors that Kimod commercialize are developed in the labs of CEA in France.
Okay. Thank
Yes.
you very much.
You're welcome.
And another question. This collaboration, Tunisia and France, how is financing of these projects affected? What is
Actually,
about? Yeah.
yes, actually, we are still purchasing financing. We talk to BAD, the Banque Africaine de Développement, and we talk to AFD. These are like banks and financial and financing companies very known in Tunisia and in France too, I guess. And in Africa. So we are still purchasing the financing, and because the project is still in its first steps. We just got the contract with the Tunisian research center on environmental field so they will make us the methane potential experiments on the waste, on the Tunisian waste. So we are really still in the first stages of the project. So we are doing the technical economic studies, and we are purchasing for the finance.
Okay. So in Tunisia, more attention is paid to on these subjects. Yes. Now.
Now, yes. just yesterday, the Ministry of Energy and Industry made a really big conference about the strategy of the industry and innovation and the energy transition into the Tunisian industry and the strategy for 2035. So yes, we are still, but we are not really. We are ahead in the Arab countries, but we still have to put so many effort on the policies, especially on the policies.
Very interesting. Thank you very much.
Yes. Thank you for your questions.
Yes, yes. You were participating on our working group, and I would, by this possibility, remind us that next week we will have a working group of Energy Alliance, and everybody is invited. It's a possibility to speak to our speakers more concrete and more detailed, because we are going to invite our speakers. They will come, I hope, and it will be a more detailed conversation on this subject. Alexander, now tell something. No, something with microphone, I think. Yes, because
I think the microphone is now on.
Okay, Alexander. Now we are. Yes, we know that you.
We will show the charging station and the trike and the scooters on these energy days, which were on the slides, and also this vintage car.
And this trial production, these prototypes, they are. It is in Chemnitz also, or not?
In Chemnitz. So the charging station was developed by our Czech partner. The company is named Elvak, and they will bring and install the charging station here. And the vehicles, they are produced by our institute and some local partners together. And they will be in car. And the vintage car is an own prototype of our institute.
Yeah, so we have to tell our attendants from we have very international audience, and we have to tell that Chemnitz is situated in Saxony, Germany, and is a big city. And I had another question to you. I know you have significant experience in leading project group and automation. Yes.
Yes.
And I know that Mr. Walter Thomas also has experience in automation, and I think that we can create here some cooperations. Yes, automation. Maybe you can tell just Alessandro some words about it now.
So I think. Can you hear me?
Yeah.
So we are starting from the classical automation to program a PLC system, motion controllers, and the entire production machinery for such systems. And yes, and within the recent years we moved we switched our focus more to the monitoring systems, which means that we are focusing on condition monitoring and also the quality control, the inline quality control with multi-sensor systems and mainly with multi-camera systems. So because there is a problem in the industry, they have not enough staff for doing the visual check of the parts. And so there is a big need for such monitoring systems in the industry. In the recent years, we switched more from the classical automation to this monitoring systems.
Okay, thank you very much. And another question to you or to Thomas, because we discussed it with Thomas already. The subject is that as a prerequisite for the future, hydrogen is now considered as a clean fuel which has unique motor properties. Yes, and to have an environmental effect, it's necessary to create serial technologies for the production and use of so-called pure hydrogen. Yes, the development of the method of electrolysis of water using electricity from solar, wind power plants, reducing the cost of hydrogen. Yes. And it's an interesting fact that at the end of 2020, a total of 4,250 buses on hydrogen transport elements were operated in the world. Yes, for example, in Germany, Flix Mobility has begun development of Europe's first long-distance hydrogen bus, the High Fleet. And in railway transport, measures have been taken on environmentally friendly hydrogen and hybrid trains and locomotives. Germany is rated as promising for the use of hydrogen traction, since about 35% of the local railway network remains unelectrified. So, and Deutsche Bahn told that they will reset all locomotives to hydrogen. Thomas, what is your opinion? How do you think? Is it maybe a question for the near future or not?
Well, as I have tried to explain, hydrogen is a very powerful element because it can store energy in chemical form, a very important part of the energy transition. Yeah. Which means you can transport it, which means you can store it. Well, what I've also tried to say is that we should look at how we can decarbonize the energy system as quickly as possible and as cheaply as possible. And that means that hydrogen will come at a very late stage. So when we have decarbonized heating, in Germany, this is a third of primary energy use. When we have decarbonized mobility, that we can decarbonize with battery electric vehicles. And for all this, you need renewable energy. And we simply don't have enough. Now, there will be times in 20, 30 years, that's my personal estimate, when we have installed so much renewable energy that we simply cannot use it any longer for these purposes. And then it's worth putting it in electrolyzers, and then it's worth to produce hydrogen, but not before. And if you read this paper, it gives a quantitative analysis of the energy needs in Europe, of the renewable energy production in Europe, and the trends, as far as the authors could research. And I find it a very transparent and easy to read. It's 36 pages document that gives this point. So research is fine, but don't use it today.
Okay, so it's the question not of the nearest future.
Yes.
Yes, so to say. Okay, but I know that Alexander, thank you very much, Thomas. Alexander has mentioned hydrogen as a very perspective form of fuel, Alexander, yes?
Yes, we have very strong activities in this direction, especially on the fuel cells, but also some projects on the electrolyzation to produce the electrodes and so on, and also to have a condition monitoring for these plants.
But hydrogen is considered in your organization in Fraunhofer Institute as a very perspective, yeah?
Yes, mainly for trucks, for big cars, lorries, and for stationary applications such as power supply, emergency power supply, and so on.
It is known that even a first tractor with hydrogen engine is in Germany now. Is in practice. It's very interesting that all these prototypes are working. And this problem of clean energy of transport is in marine transport very actual. Yes?
Maybe also one remark regarding the usage of hydrogen in the industry. We also have some some projects where they we have some forges, some industrial forges, and they are switching from natural gas to hydrogen to have some cleaner footprint in their production. But the problem is the hydrogen is very aggressive to metal parts, especially you have such an embrittlement effect, and this is a very big issue for having some better understanding if the existing components will survive this hydrogen acquisition. You have this embrittlement of metals due to hydrogen.
Very good, very good. So now I have to ask Mr. Grutz. Mr. Grutz is Vice President of European Synod and Director of German chapter of European Technology Chamber. Benedict, where are you? Benedict? Benedict? Just a moment. Benedict, yeah. Mr. Grutz, something is wrong, yeah? Just a moment. So I think that we had a very, very interesting discussion, and I would like to invite our distinguished speakers, Mariam Hassan, Alexander Pira, Thomas Walter, to our working group next week, because I am getting many requests for further discussions on these topics, many practical interests. I would underline our main goal of all events. It's our business opportunities, new business opportunities, and another main goal to involve our members, advocates, and guests to the programs and tenders for funding grant programs of European Commission. Unfortunately, I can't find Benedict Grutz, who should present these 3 certificates, yes? And that's why I will send it to Mr. Pira, Mr. Walter, and Dr. Walter, and Mariam Hassan. I will send these certificates today, yes, the 3 certificates. Certificates about trees who are planted, and all these trees have names, personal names, so they are planted for you, for our speakers. We are very thankful, and many thanks for your readiness to speak, to give your opinions on these very interesting and actual subjects. And we will put all the informations in all social media, Twitter, LinkedIn, and so. And thank you again. Now we have to finish, and I see, or I hope that we will meet next time for our interesting discussions, and very many thanks to all our attendants. It's more than 160 registrations. They are writing, they are calling me now, but we have not enough time, and we will do further work during our next working meeting next week. Thank you very much, and have a nice day today. Thank you.
Bye-bye.
Bye-bye.
Bye-bye.